So problem 1 asks us to use the fundamental theorem of calculus part 2 to evaluate the definite integrals. So the fundamental theorem of calculus part 2 says we anti-differentiate and then we use the antiderivative and evaluate it at b and then subtract the same function evaluated at a. So for this first one, we can use the power rule to anti-differentiate, and we can say, well, the antiderivative of 4 is 4x. The antiderivative of x squared is x cubed over 3. And now we want to evaluate this from 0 to 2. So first, I plug in 2. And then, because I'm subtracting the entire expression evaluated at 0, I need parentheses, and I see I'm going to get 0 minus 0. So if I clean this up a little bit, I get 8 minus 8 over 3, which is 16 over 3. So now we've computed the exact area under the curve without having to use Riemann sums. B, we have x cubed, so that's going to be x to the 4th over 4. But the antiderivative of negative 3 to the x is negative 3 to the x divided by the natural log of 3. And this we're going to evaluate from 1 to 2. So we get 1/4 minus 3 to the 1, which is just 3 over natural log of 3, and then minus, oh, sorry, I'm supposed to plug in 2 first. So 2 to the 4th is 16. 3 squared is 9. Now I plug in 1, so I get minus 1/4 minus 3 over natural log of 3. So I can clean this up a little bit because 16 over 4 minus 1 over 4 is 15 over 4. And negative 9 over ln of 3 minus a minus 3 over ln of 3, that gets added in, and so I get minus 6 over ln of 3. And that's about the best we can do. This next one, well, we can't anti-differentiate a quotient rule, but I can rewrite this integral where I split these two things up so I can use the power rule. So this is 2 over x minus 3x dx. So the 3x squared over x, one of the x's would cancel and you just get 3x. So this is 2 times the natural log of the absolute value of x minus 3x squared over 2, and this is going to be evaluated from 1 to 7. So I plug in 7 first, so it's 2 natural log of 7 minus 7 squared is 49. So I'm just going to have 3 times 49 over 2 minus, now evaluated at 1, the natural log of 1 is 0 minus 3/2. So I'll have 2 natural log of 7. Since these have the same denominator, I could combine them, but it's perfectly fine to leave them as they are. So because this is a minus minus, it also gets added. The next one, I want to rewrite it so I can use the power rule. So we're going from 1 to 3. So 3 over the square root of x is the same thing as 3x to the negative 1/2 minus x to the 2/5 dx. So now when I anti-differentiate, I'll get 3 to the positive 1/2 divided, 3x to the positive 1/2 divided by 1/2, which is the same thing as just multiplying by 2, minus x to the 7/5 divided by 7/5, which is the same thing as multiplying by 5/7. And we're going to evaluate that from 1 to 3. So I'm going to plug in 3 first. So 2 times 3 is 6 times the square root of 3 minus 5 times 3 to the 7/5 all over 7 minus, now I'm going to plug in 1, so I get 6 times the square root of 1, which is 1, minus 5/7. And you can just leave it just like that.